Hello folks, welcome to Rational Science, the only site on the internet that does physics. Everybody else does mathematics. Mathematics is the movement of concepts. That's what everybody else does. Okay, we have a good day today. We're going to have a review of what we did in the month. Okay, I'm going to start with our criticism of the criticizer. There was a fellow who criticized the scientific method. Can you believe that? Criticizing the scientific method. What arguments could he possibly have? Well, here it is. Let me put him on, and I think he was, hi. We have this person, he said that you need to test explanations. Before he said we have to test hypotheses, which are assumptions. You know, and now he's saying his argument is you also need to test explanations. Okay, so here it goes. Give me a second here. Here it goes. This fellow claims that in science, in his version of science, you must test the explanation before it can become scientific.
You have to test these explanations. And if you can't test these explanations, well, then you're not doing science.
Okay, so he says we have to test the explanations. What could he possibly be talking about? I mean, you know, like I said, he talked last time, the previous time, he said, talk about you have to test the hypothesis. A hypothesis is an assumption, you know, and so we make an assumption, like you might make an assumption in quantum mechanics saying that light is mediated by particles, okay? You can make that assumption. How are you going to test that, okay? You know, you can't test it. And test an explanation, well, even if you test it, all you're doing is convincing yourself or convincing someone else that your theory is correct. That's what he's talking about. Okay, and here's the rundown. Okay, give me a second here. Okay, test a hypothesis is to test an assumption. We don't test assumptions. We accept them at face value in order to understand the theory, the explanation founded upon those assumptions. Test the explanation. Well, you know, what are you doing? You're just trying to convince someone. Okay, what are you going to do? Run an experiment or what? Okay, what do you want me to do to test the explanation? Yeah, especially on something that is invisible and intangible, such as the mediator of gravity. What are you going to test? You're going to run an experiment to test, you know, my magic wand here. You're going to test what's up here, what's down here. What invisible thing is pulling, what invisible thing is pushing. Intangible and invisible. I mean, it doesn't make any sense to say you're going to test the theory. Theory is one that you listen to, you understand it, so you know, just to comprehend it, that's it. There's no more than that in science. Someone might say, may have an assumption saying God, okay? So the individual introduces God. And then he says, my theory is that God created the universe. Okay, and so he goes on and he says, yeah, God moved his magic wand, said voila, and there was the universe. Great, that's his theory. That's what he believes in. This is how he visualizes the origin of the universe, okay? And so when you look at that, you say, okay, that's his theory, okay? Now you can criticize his assumption, you can criticize his theory, but test it. How are you going to test that God is out there? I mean, what experiment do you propose? It doesn't make any sense. So yeah, to test a theory, as he said, all you're doing is actually focusing on religion, on belief. What you're doing is, you know, persuading, convincing, converting, and recruiting. That's the elements that you're considering when you're talking about testing an explanation. And that's what the prosecutor does with the jury. He tries to convince the jurors, okay, to his side of the case. And it's also what a priest does, you know. What does he do? He talks about whatever, and what is he doing? He's trying to convince the flock. That's it. So so yeah, experiment, trial and error, that's technology. We don't do experiments to test either the hypothesis or the theory. You can run whatever experiment you want at home, no problem. Go ahead and run your experiment, do whatever you have to, stand on your head if you need to. But when you come to the conference, we want you to tell us what you learned. Tell us a mechanism that we can use in physics. Okay? And so you say, this is how I think gravity works, or this is how I think electricity works. Great. And you tell your theory, and people might have questions, might attack it, might defend it, whatever. But the issue here is the attacking and defending, the saying it's correct, incorrect, true or false, that's belief. That's got to do with opinions, religion. The theory is just what it is, objectively. You just try to understand it to see what the guy has going through his mind. That's it. That's all there is. Okay, we also had the Moonies this week, okay? The Moonies. Who are the Moonies? The Moonies are people who believe that we did not go to the moon. Humans did not step on the moon. Now, I essentially believe that humans went to the moon. There are some issues that I cannot explain, so if a Moonie approaches me and says, well, Bill, explain this or explain that, there are some things I personally am not able to explain, okay? Does that mean that we should throw the baby with the wash water away and say, oh, that they never went to the moon because I can't explain this? And that's where I draw the line. One thing is to say that I cannot explain certain things that I'm staring at, and another one is to think that because of that, man did not go to the moon. Okay, so two different things. And we have all these people. One of them here, he says they can't see, they can't create the effects seen in the ISS footage using cinematic techniques. He's talking about, what I showed the other day, that the astronaut was floating in there and so on. And he says they can create that in the lab. They can do that in Hollywood. Okay, watch the movie Gravity, which I did, by the way, a while back. Okay, and the mini does the, I guess, mini series. Does that explain how the microgravity scenes were achieved? Okay, and so I went in there, and here's what I found. Okay, this is the astronaut on the ISS. Okay, this is what I showed the other day, and you have this guy floating around. But I want you to see his little computer, his little palm top there. Okay, he's got it all over the place. It's just floating. And this fellow says that, or believes that, this can be done in a lab, in a, in a Hollywood studio or whatever. That this is all done with green screen. Okay, now we can maybe imagine this fellow being floated by wires and doing all this. A little harder is to do what he's doing with that little computer. Okay, that's what I want you to see. To show me how that's done with so much sophistication. Here's this other astronaut. Okay, and she goes in there and she releases a drop of water, big drop of water, by the way, and she swallows it. And how do you do that trick with a drop of water? Okay. Don't tell me you don't believe it. Don't tell me this is done in a lab. Tell me how you do the trick, even in Hollywood. I mean, show me how that's done. And what I can show you is the following. Give me a second here. Let me get rid of this gal here. And here I have how they filmed. This fellow says, go watch Gravity, and go watch how they filmed it. And here are snippets of how they filmed it, how they filmed this movie Gravity, the scenes that concern us here. Okay, here it is. Give me a second.
Extremely long shots, these very fluid 12-minute, 5-minute or 3-minute long shots. It took a while to work out.
Tim and Chivo developed this technology in which the actors are inside a cube of light.
The three main elements of the light box are the robot moving the camera, the light box moving the lights, and the tilt rig moving the actor.
Okay, now that scene with the computer, the scene with the drop, first of all, you can't do that. I don't think you can do that at all in Hollywood, okay? What are they going to do, hold the drop with a little string? That's one. And the other one is that certainly what they did with gravity did not exist in 1969. This technology for filming was later on discovered. Okay, so put it in the right time frame. Some people are extrapolating what they do in Hollywood today with the abilities we had in 1969, which is when they went to the moon, right? So, you know, you got to distinguish that as well. I don't think they can do this even in Hollywood today so perfectly with a little drop floating there and all these things, all the movements of the computer. I don't think they would be able to do that today so easily. In fact, when you watch how they made gravity, it took them a long time just to get the general scenes. The easy scenes are, you know, pulling someone with the strings and moving them around. That's the easy part. Doing the little things that are out there, and I only saw one scene where they have this wrench and it's just floating very slowly in there. Yeah, they could have done that one with wires. But not, I don't think they could do this drop or anything like that so easily, okay? And again, that would be today, if anything. So, you know, I'm not convinced that that any of that, the astronauts on the ISS, that was filmed in Hollywood. No way. But some people believe that, okay? And here we have another fellow says, look up the video called John Young's Lunar Salute, okay? It's actually one of the very best proofs that the moon landings were faked in a studio with astronauts supported by wires. The sand that the astronaut kicks up during the jump goes as high as his foot, but lands long before he does. Under gravity, both sand and astronaut would hit the ground simultaneously, okay? Like the famous hammer and feather drop test, okay? The astronaut is being pulled up on a wire while the sand falls naturally according to gravity. Look carefully. Smoking gun. Well, you know, somebody answered him, and this is their answer, okay? Let's go with that first. He says, oh, sorry, got the same one. Well, the fellow said, sorry, I got the wrong one there. Anyways, the fellow who answered him says, you know, I watched the movie, and, you know, I didn't see anything. And I didn't see anything in it. I watched there, and I didn't see absolutely anything. Here's what you see when you look at that movie, okay? You see the little sand falling on the shadow, and here it starts again, okay? The astronaut jumps, okay? And if you look at it, if you watch that little movie, you see an analysis of the fact that there is dust falling there, okay? And it's falling right under his feet, because they say when you take the shot from the front, you don't see the particles fall. And no, that's not true. This fellow took the trouble of filming this in slow motion, getting a good shot, and he said the particles are there. So, you know, what some of these people believe is a smoking gun, that's just their belief. Nothing more than that. They haven't proved anything. At least, you know, certainly that's not a smoking gun. Under no circumstances. So, you know, again, people are raising things just to win an argument or because they have strong beliefs, but they don't make their case at all. Would not make their case in a court of law. Okay, here's another fellow. That luminary in the sky, talking about the ISS, right, is most likely a powered Mylar helium-filled balloon. Or drone. It's a drone, okay. Soaring at roughly 30, etc., etc., etc. And again, the movie Interstellar and Gravity, you know, and they say that that's what they're obsessed with. They think that because that was done in a lab, then, or in a studio, NASA could have done in 1969 and all the way back, all that stuff also in a studio. And first you got to distinguish the times. You know, the fact that in those days they didn't have all the Hollywood technology to do some of these scenes, or had not developed them to that level. And then the other thing is that, you know, today some of these scenes can't be done. Okay, I think it's easier to send a man to the moon than to do some of these scenes that these people say, oh, that was done in a studio. Okay, and here we have this fellow who I showed the other day, and he filmed the ISS from his home. Okay, and you can see it there. I don't think this guy is trying to fool you or anything. He's just an amateur. He took a picture of the ISS. Not only did he film it with his telescope, he also took a picture of it. So people who deny this, instead of talking, people should go out there and see if they can see it with their binoculars. NASA has the route, the time when it goes through each country. It passes 15 times a day through a given region, and the NASA has it scheduled. So there should be no reason for anyone not to focus on the ISS and locate it. And, if you don't have a binocular, well, at least don't talk. Don't say that it's not there. First verify that it's not there. Verify the schedule. Verify when it goes near your region, that over your house or whatever. And then go and try to see if you can see it. If you see it, we're done. This is a black or white issue. And I like the ISS because, see, you can say that man did not go to the moon, we did not go into space. You can argue anything you want. What you cannot argue is that there is a big monster orbiting the Earth. Now that's a smoking gun, which goes against all people who say that we never went to space. Because before you can put that thing up there, which was built in space, by the way, over a period of 10 years. You don't have to believe that either. But for sure, to put that big monster up there, you got to tell me how they got it up there. Okay? How did they get it up there? A couple of rockets that took it up there and just sent it rolling along? And if we can do that, why can't we send a man into orbit, like Gagarin, who went into orbit? If we can put a thing there that's orbiting the Earth and you can see it every 15 times a day, every 90 minutes, well, it seems like, first of all, I don't know why they would do that. If they're not going to put a man in there or some people in there to do some experiments, okay, so it's just a tin can that's floating around. Great, no problem. That means we can send rockets at least in low Earth orbit, empty rockets, right? And this was the first one that they sent up there. If this one did not exist today, if you did not see it there, you would say we never sent a rocket into space, even to low orbit, because there would be no way to show you otherwise. But if we can see this, that big monster, then you have to conclude that there were some intermediate steps before we got to that point. And that means that we had to have sent, before we sent that monster, we had to have sent rockets at least into low Earth orbit. So if you deny that, well, I don't know what to tell you. You're just an extreme Mooney, and all you're just trying to do is win an argument. You can verify whether the ISS is up there, okay? Then the next step is to find out if there are people inside there, doing experiments, floating with that thing all around the Earth, which is the second level, okay? Can we send a person up there that high, 400 kilometers up there, okay? And so here's another fellow. He says, there are other plausible explanations for what's taken to be the ISS in the sky. Okay, what is it? One possibility is that the visible phenomenon is introduced by variations of the technology used to generate laser guide stars, which excite plasmas in the upper atmosphere with ground-based laser. Well, if you look up that laser guide stars, it's used to highlight certain patterns in the sky, okay, at a given region. This person is confusing laser guide stars with this, what you see up there. You see lasers that create some images up there, and they say, see, we could have done that same thing with the ISS. And that's absolutely not true. Okay, the reason it cannot be true is that the ISS goes all around the Earth every 15 minutes. You think that they're going to take the trouble to have a laser go all around the Earth in every country, and they point that thing up there so that anyone can pull out their telescope or their binoculars and see it? And would they see the lights impinging upon it like you see there. Okay? So, these people are just looking for arguments to win the day. That's all there is. These are extreme moonies. All you have to do is pull out your telescope, point it at the sky, and see if the ISS is there. If it's there, you got to keep your mouth shut. Okay? It's just that simple. Okay, here's another. Fellow says, a 747 is barely visible at 35,000, yet the ISS is visible from what altitude? 400. Okay, 400,000. So I don't know what to tell you. These people just don't want to believe that you can see this thing when here this fellow is filming it with a telescope. Can you see the moon with a telescope? Because maybe you don't even believe that you can see the moon with a telescope. I mean, I have a pair of binoculars. I looked at the moon. And I don't have a telescope, but I do have a pair of binoculars, and I look at the moon. I have looked at the moon several times. And one of these days, I haven't looked at the ISS yet, but one of these days I'm going to try it with the ISS. Not because I have doubts, okay? Any more than I have doubts that I'm not going to find Santa Claus in the North Pole, okay? So I don't need to go there to find out if Santa is really there. But the ISS, it's just for curiosity to see what it looks like and see it go around. But I have no doubts because there's so many amateurs out there. We're not talking about NASA here. We're not talking about the European Space Agency. We're talking about amateurs who point their devices up to the sky and they say, okay, I'm going to look for the ISS according to the schedule set by NASA or any other organization that's affiliated with the program. And you should be able to see it. Just don't talk if you've never tried it. Don't say it can't be up there. I mean, all these amateurs, they're all just BSing. No way. I don't buy that. That's why I don't need to verify the ISS, that the ISS is up there. I'm just saying I haven't seen it myself. But again, I haven't seen Santa Claus, and I'm not going to verify whether he's out there. Okay. Okay, here we have another one. You immediately notice my crass ignorance on the subject. Yeah, I noticed this crass ignorance. And this is what he said. Many people have demonstrated beyond a shadow of a doubt that it was impossible for 50s, 60s technology to get to and from the moon safely. I saw exactly the opposite. I saw many trips to the moon, unmanned probes, and they reached the moon without any problem. So why would that be different with a human in it? Okay, so when he says that many people have demonstrated to him, okay, let's make sure we understand that. He's talking about belief. Okay, he's not talking about the capability we had in the 50s or 60s. He doesn't believe we had it. Okay, even today with 2022 technology, humans cannot go to the moon and return safely. I don't know why he says that. Sure we can. We can go to the moon and back. If we hadn't gone in the last 50 years, there was no need to go there. There was no need to go there in the first place. Okay, maybe to develop technology, maybe it was a nice experiment, like saying let's go to the moon, let's collect some rocks, see if there's anything different over there than over here. It's that sort of thing. There's always money from a big empire like the United States to do that kind of thing, or for the Russians. They can do those things because they have some money left over for those kinds of projects, which help them develop military technology in the process. And, it's good. It's good for technology. Okay, so that's why they do it. But then after that, you're not going to go to the moon every day and put a base there, none of that. What for? What are you going to put a base on the moon for? Mining? And again, you're not going to be mining on the moon. Some people believe they will, but I think they're crazy. Because, first of all, to take the equipment up there is a monster. You would have to have many trips just to take the equipment up there. Then working in those conditions, I'm not sure it's so easy. And then what are you going to collect? Some rocks there and then bring them back to Earth? How much are those going to cost? So no, there's no way that that's going to be happening, ever. I don't think it's ever going to happen. And so, what can I say? I think that people who say that we have no capability today, they're crazy. Of course we have. We've been sending probes to the moon, unmanned probes, for a long time. We've sent them to Venus, we've sent them to Mercury, we sent them to Mars. And these people are going to say that never happened. Well, again, and is there an ISS? And if we got the ISS out there, weren't there some previous steps that we had to take in order to get the ISS eventually up there? Hopefully the answer is yes. Hopefully we sent many probes in low Earth orbit before we sent that big monster up there. And those never happened. So you got to check the NASA program or the Soviet, Russian program and find out how many probes they sent out there. And there's a list of them in the Wikipedia, unmanned probes. If you say, well, I don't believe in that either, which, I mean, you're just a flat earther who's closing his eyes. That's all you're doing, okay? You're just extreme moony. And this is not about extreme, it's about trying to show physically how we went to the moon on the one hand, and if we did not go to the moon, let's concede that as an assumption, how did they do the trick? Show me the trick. Show me how that gal swallowed that ball of water. Show me how the other guy played around with his computer twirling around. Was it held by little threads from everywhere? Is that how they did it? Okay. Not that kind of motion that you saw there. Okay, that's the issue. When you have sophisticated motion like that, that's not Hollywood. That's up there in the ISS. Okay, I said, I do not see facts as not scientific like you. For me, a fact is, among other things, something measurable and observable. Okay, I can measure the length of a cube. I can measure sunset, sunrise. I can observe the ISS. One guy who at least observes the ISS. Thank you. What I measure and see are, in my definition, facts. Okay, so this is what he calls a fact. If you say that, if you say no, that's just belief. You have to show me that measuring the length of one side of a cube has something to do with belief, and you can measure something totally different. Okay? And so, yeah, again, the issue here is that people like him, they think that a fact is something that, again, that he can measure. And I measure it, and I say, and I reach a different conclusion. Whatever. He measures the table, he says it's 1 meter, I say, no, it's not. And he says, measure it. No, I'm not going to measure it. I just don't believe you. No, but it's a fact. No, I don't believe you. And I don't believe, I don't believe, and I don't believe, and I don't believe. Just like these flat earthers, that extreme moonies who say they didn't see the ISS out there. You say, no, but it's up there. Here's the telescope. Look through it and you'll see it. And they say, no, I'm not going to look. And even if they do, they see, well, that's a bird. I mean, they can say anything. They won't believe your fact. Under any circumstances. You ask them to measure and they say no, or if they measure they say something else. They say he measured something else. So you have people out there that will not believe under any circumstance, no matter what. So fact is always your personal belief. That's why I say in science we don't have facts, we have statements of the fact. You make a statement of what you think is the fact. It doesn't mean the audience, the entire audience, the 100% of the audience is going to accept your fact as a truth, as something that really happened or that is. Okay, they might concede the assumption, say, okay, let's concede this assumption, okay, and see what theory is founded upon it. But to say that it's a fact and that's it, and if you don't believe me, just do it yourself and you'll find out it's a fact. I may say that I'm not going to do it, and I may do it and say that I got a different result. And so your fact is not my fact. Do we have facts for space-time? Is that a fact? Is electron a little bead that rolls around a proton? Is that a fact? And so, we can go on and on and on. What is a fact? It's what you claim to be a fact. You measure the table 1 meter, I say I measure 1 meter and 1 millimeter. Okay, so we have a different reading. Which one is the fact? And we can go on and on and on. There are no facts. There are only statements of the fact. You can even tell someone, look, the number pi is the ratio between the circumference and the diameter, or whatever, Pythagorean theorem. You can bring anything you want. 1 plus 1 equals 2. And the other guy says, it's not a fact. Not for me. And you say, no, but it is. Yeah, and they go say, oh. And what are you going to do? You're going to kill him? He's just going to say, no. So no facts in science. Science, we make statements of the fact. so that people accept it at face value, and then from there proceed to understand your theory, okay, founded upon it. But talking about the moon, I said that one of the reasons that they put the little seed of doubt in me was that I heard Armstrong, I'm not going to show it again, but I showed that clip, and I thought it was a very strange reaction from Neil Armstrong. Of course, later on I saw other parts where this guy was chasing Armstrong around to get him to swear on the Bible that he went to the moon and Armstrong wouldn't do it. And she said, why won't you do it? And blah, 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 here's the book. And Armstrong gave him the right answer. He said, I think that Bible is fake. But here we have another individual, and he was an astronaut, Alan Bean, okay? And I liked his answer, and it convinced me that, I want you to listen to this guy, and I think you're going to agree with me that he's telling the truth. He says he went to the moon, okay? So he had a little different attitude than Neil Armstrong, but I think you should listen to this. Here goes.
They're clearly pretending to be halfway to the moon when they're not halfway to the moon.
That is, I don't care what you say. I went to the moon and back, and everyone that's a scientist knows it. Now, if you want to not believe it, it's okay.
If you walked on the moon, here's the opportunity to set the record straight,
Okay.
to put your
Okay.
left hand on the Bible,
Left hand.
raise your right hand,
Okay.
and you realize this can be used as a video deposition in the future, and if you lie, you'll be guilty of perjury.
I understand that.
Okay, say your name.
My name is Alan Bean.
I swear to God and affirm,
I swear to God and affirm,
under penalty of perjury,
under penalty of perjury,
treason.
treason. No, not treason. Treason has nothing to do with it. Let me rephrase this and say, I've got my hand on the Bible. I went to the moon. I walked on the moon. All the other people that you think are people that NASA says went to the moon and walked on the moon
But you won't-
did go to the moon and walk on the moon.
You won't say under penalty of treason.
What's treasonous?
That's doing something fraudulent to the taxpayers.
That's crap.
Well, what
That
about
isn't
under
treason.
penalty of eternal damnation?
Under penalty of eternal damnation.
And under penalty of treason.
Treason is when you sell out your country.
Well, if you used $135 billion to not go to the moon,
That's still not treason. Treason is if you tell secrets to another thing. I've said enough. Now you can use that and say, well, you didn't say something else.
No.
I know how people are. It's okay.
Well,
take your stuff and get the f out.
I thought he was very good at that. I think Alan Bean was being very honest. I think he would have passed the lie detector, okay? He's telling the truth. I didn't see anything wrong there. I had a problem with Neil Armstrong's attitude. I still cannot explain it. But this fellow, he was straightforward. I have no problem believing him, okay? Here's another one, just in case. We're going to have two of them so that all those who believe that we did not go to the moon at least listen to these testimonies. And I think any rational person would say that these people are being honest when they say they went to the moon. In this case, the guy, just like the other fellow, they were surprised because they didn't know what was happening really until they got the hang of it. And they said, oh, this guy doesn't believe that we went to the moon. Okay, they didn't understand that at first. Listen to this fellow. Okay, this is Mitchell. Okay, here goes.
what is this? They're talking about shadows and stuff like that. What is that all about?
You know, this might have come from some of the challenges to the fact, from the challenges by the group that has said we never went to the moon, and they're trying to pick holes in some of the lunar photographs. And it's an interesting subject because they're totally misguided. We did exactly what we said we did. And they can try to pick holes in the photography all they want to, but
he ended up kicking this fellow out of his house. So what can I tell you? You know, some of these people, like this fellow, he's just exceedingly insistent. He's obnoxious, and he only made the astronauts look good, because I think the astronauts were candid. They were saying straightforward that, yeah, they went to the moon, until, you know, they figured out that this guy was really putting them on the spot. Okay, but no, I'm convinced that they went to the moon. Now, there are questions I cannot answer, okay, not because of that. Again, I'm not going to say that they did not go to the moon. The main reason I think they did is that we did send many probes to the moon, the Russians and the Americans primarily, okay. They sent probes to the moon and to other planets, and if we can send a probe all the way to Mars and all the way to Mercury, in fact, some that went out of the solar system, I think we have no problem in sending a probe with humans to the moon and back. We're talking about an orbit around the moon and coming back. That's it. And to say we can't do that, no. We did it with unmanned probes. There should be no reason not to do it with manned probes. And that's my primary reason for thinking that, yes, we did go to the moon. Okay, let's move on here. Here's the recap for this month, and little summary, okay, here. We have the version of mathematics, and we have the version of physics. Okay, what does mathematics believe in? Well, they believe that space is a thing. To this day, they've always thought that space is a physical entity. Okay, that there is something out there called space, and that space is usually made of particles. Okay, but they see it as a container, either as a container that contains all the stuff that's in there, okay, or it itself is made out of particles. Those are the two versions that mathematics has, okay, and it's had it for at least 2,500 years, since the days of the Greeks. And within that, you have position. Where did we discuss position, which either the Greeks called it or it was translated as place. Okay, place and position are synonyms, but it's what it is motion, because what they're talking about today, as far as position is concerned, is an ordered pair or triplet or whatever. In other words, they're talking about coordinates, how to get to some place, and how to get there is called motion, not called position. Okay, so if you need to go 10 feet to the right and 5 feet north or whatever, they're giving you instructions on how to get there. That's not a position. That's how to get to the position, to that dot, to that location. Okay, and so position and motion are synonyms in mathematics. Distance is a synonym of displacement, because distance is really distance traveled. What they're looking at is how many feet, how many inches, how many meters, how many kilometers or miles. They're talking about a measurement, a number followed by a unit. That's what they're talking about when they're talking about distance. Okay, so they're not talking about qualitative separation. They're talking about quantitative motion. That's what they're talking about. Okay, and again, all that's got to do with mathematics, because that's not what distance is. Distance is just separation. And distance is not length. They're not synonyms, except in mathematics, okay, because they say, well, distance is the length, blah, 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 blah. And what's length? Length is the distance, blah, 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 blah. Why? Because they have to unroll the measuring tape, the tip of the measuring tape, whether they measure distance, length, or whatever. So for them, it's always the same, and these are all synonyms. But in science, no, they're different. Distance is separation between two objects, and length is the qualitative separation from one edge of an object to the other edge, the one that you're measuring, right? And you're saying there's this separation between this surface and this other surface, and you treat that as if it were made of continuous matter. So if you're going to measure a table, you say, what's the length of the table? And in physics, we don't answer with a number and a unit. The length of the table is the separation from one side of the table to the other side of the table. That's the length. It's the qualitative separation from surface to surface, treating everything in between as if it were a single piece. Like if there's no space, holes in there, you know, no space. It's just a single piece made of a single piece. Motion, what is motion? Well, in mathematics, they define it as change. Change this, change that. Change is a synonym. when you're talking about change, you're already talking about motion. So you can't use the word change, or like someone will use in another definition, phenomenon. No, it's not a phenomenon. Phenomenon is already motion. So you can't say motion is the phenomenon, blah, 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 blah. No, that's an irrational definition. It's a synonym. It's a circular definition. Okay, how is it in physics? Well, these words have a little different meaning in physics. Physics, space, we define as that which has no shape. Okay, and so you have all the matter in the universe, any object that you wish to isolate and say, this is the object, okay? Could be a chair. Maybe that's all that God made, just a chair. Maybe he's just building the universe and he started with a chair. So he only built a chair, okay? And so we say space is what gives it contrast. And it can't be a thing, because if space is a thing, it has to have shape and has to have something outside of it giving it contour. That's why at some point the buck has to stop. You can't continue saying, well, space is an object. Okay, if it's an object, what's outside of space? What gives it shape? Okay? And if you say, well, it's time or it's intelligence or whatever, I don't care, then what gives shape to that? And so on. And you'll never stop. That's why they ended up with 26 dimensions in string theory and they finally got tired. Otherwise, they would have continued to 10,000 dimensions. Position, the object itself. Okay? Whatever object, whether it's a table, whether it's a lamp, whatever, the volume it occupies, that's the position. That's why we don't use the word position in physics, because position is the object itself. Okay? And location, well, once you define distance, which you see there underneath it, separation between objects, you have one object with respect to all objects in the universe, or whatever subset that you use of that universe, and you say it's the separation from one object to all other objects. The set of all that separations, that's the location of that object. That can only be visualized in a single frame of the movie, okay? So of the universal movie. For a given cross-section of time, given cross-section of motion, you have only one frame, one location. Everything in the universe at that frame of the movie, of the universal movie, has only separation from everything else. And that's the location of that object at in that frame. Okay, so this is what location is, just separation between objects. And motion, you have to have two or more locations. You need two frames of the movie, of the universal movie. And you can make the movie the frames as small as you want. It's got nothing to do with smallness. It's got to do with it being a cross-section of time, if you can imagine that, or a cross-section of motion. You're looking at location, which is a static concept. That's all that there is in that frame of the movie, of the universal movie. So you have every planet, every star, every asteroid, every atom in the universe, for a given cross-section of time, cross-section of motion, everything for that single frame of the movie, of the universal movie, it's only got distance between them. That's it. And that's what we call location. What is the location of the sun? Well, this is the location. The separation from every object in the universe, every atom, for that frame of the universal movie. Okay? It's a conceptual issue. That's how we visualize it. That's how we talk about location in physics. And so here's a little summary of mathematics versus physics, okay, related to this. First of all, there's no definitions in all of mathematical physics, okay? No definitions. Not one of the words which is crucial to do physics is defined in mathematics. In fact, none of the ones that they use are defined. You know, you look for the word point and line, which we don't use in physics, okay? And you look up the word point and line, they say it's undefined term. That's what you'll find. You know, in the end, they'll say, well, it's an undefined term. We can't define it. And they can't define it because they're trying to merge a concept with an object. They have the dot, which is the object, and they have location, which is a concept, and they're trying to replace the concept location with a little ball there, a little dot to the spot. That's it. And so they say, well, what is the point? And they say, well, the point is the location. Well, if it's the location, why didn't you use the word location? And so this is the problem. There are no definitions. They don't know what energy is. They don't know what time is. They have no definition for mass. They have, in fact, they have like 7 of them according to the Wikipedia. So none of these words have definition. Then they define field as they have all these values in space, and they say it's just all these numbers with units around a encapsulating ground zero, right? And they call that a field. Okay, so it's a bunch of numbers, great. And then they say, well, the field moved the charge. The field did this, the field did that. It vibrated. What do you mean it vibrated? What do you mean it pushed a charge? What sense does that make? You said that a field is a bunch of numbers. So this is the problem. None of these words are defined, or they define them in one way and use them in another way. They're not consistent with the usage of what they defined. That's the problem. And then they have all these things. They say observation is part of science, the scientific method. What are they talking about? They're talking about gawking, drooling, because the fact that you observe does not mean that you understood. Okay? And again, it's introducing the observer, the witness. You're introducing witness into science. That's okay in the legal world. You know, the prosecutor brings a witness, says, "What did you see?" And says, "I saw this." That's testifying. That's that person's belief. And that's fine. You know, you can accept that at face value, but we don't do that in science. We can't say, "Oh yeah, I observed." And because you observed, now it's a law, it's a fact. Not in science. Okay? Predictions, well, that's astrology. These people say that they can predict. Why? Because that is a key element of mathematics. If you're going to do an equation, like you say, or you measure something, you measure the speed of a car, and you say, well, the car is running at 50 miles per hour. In 1 hour, if it's on a straight line, for example, right, it's going to be, you can predict it's going to be 50 miles away. That's science, that you can predict where the car is going to be because it's going at a steady state or a constant speed of 50 miles per hour. Again, you know, what's that got to do with science? The fact that you can predict. And you can predict there's an eclipse tomorrow. Okay, so you predicted the eclipse, and it happened. 2 o'clock tomorrow in the afternoon, there's your eclipse. So what? That's a description. And only if you can explain it do you go back to the past, because explanations are exclusively of the past. So if you can explain why there's going to be an eclipse tomorrow at 2 o'clock, all you're doing is pulling from your experience. That means you've already had some experience with eclipses. Otherwise, you would not be able to explain an eclipse. The person who sees an eclipse for the first time in his life or hears about it, you know, if he can explain it, it's because he's got some exposure to it. He's got some background with it. He's talking about the past. Explanations belong exclusively to the past, and that's what science does. Explanations. Science deals only with explanations, with the past. Predictions has nothing to do with science at all. We don't care what you can predict. You can say that, you know, I let go of the pencil, okay, let go, falls to the floor. And I can predict. I'm good. I took a course in astrology. Here, let go of the pencil, and here, watch it. I'm going to prove to you, you're right, that it's going to fall to the floor. Okay, there it is. Fell downwards. And so once we have that, did we do science because I can predict that the pencil falls to the floor or will fall to the floor? So again, predictions have nothing to do with science. The reason the mathematicians are so fond of predictions, they say, oh, it proves that my equation was correct. But what is an equation? An equation is a tautology. You've measured something and you say, this is the equation. What is the equation? It's a representation of what you measured, essentially. Okay, so it's a tautology. That's got nothing to do with science, with physics. Measurement, again, you know, you can measure all you want. You measure the table, you're a scientist. You did the scientific method because you measured a table. You know, again, measure the weight of someone. Oh, I'm a scientist because I measured their weight. Great. Equations, again, descriptions, that's all an equation is. There's no, you know, an equation does not give you an explanation, does not tell you the cause, the mechanism underlying a phenomenon. The only thing an equation can do is describe, and that's all that mathematics can do. That's why they emphasize description and not explanation. They cannot explain. They cannot explain why the pencil fell to the floor, for example. The cause, the mechanism, how Mother Nature does that trick. In order to do so, you need to make the invisible objects that Mother Nature uses visible. Okay? That's what you got to do as a theorist. If you're going to explain a mechanism, the cause, what brought it down, well, hopefully something's in contact with a pencil, something that you can't see or touch. That's what it's all about. Then they have this mixture. They say that hypothesis is the same thing as a theory, which is the same thing as an explanation. Well, not in science. Maybe in mathematics, but not in science. Hypothesis is a set of assumptions that you're going to introduce in order to understand the theory. It's what you're going to base your theory on, your explanation on. And that includes also the objects and the definitions. You have to have the objects that you're going to be using, you have to present them to the audience before you move anything in your theory. So if you're going to talk about why the pencil fell from the Eiffel Tower all the way to the floor, hopefully the first things you identify are the pencil, the Eiffel Tower, the floor, so that people can follow your train of thought. You cannot say, I have an X and it's above a Y and it's going to fall to a Z. I didn't get any of that. What are you talking about? No, you illustrate them. You illustrate the Eiffel Tower, the pencil on the floor, and now you can explain, the cause, the mechanism of what caused the pencil to fall to the floor. That's the way it works, okay, for physics. Okay, so no, a hypothesis is not a theory, not an explanation. It's the set of assumptions that you need to establish before you found or you base your theory upon it. And then, a theory is an explanation. Yeah, theory is an explanation. And in the case of physics, it's an explanation of a mechanism, the causes. You want to understand the causes. Case of philosophy, it's different. It's the purpose and reason. That's what you have to explain in philosophy. And yeah, math is, they claim, mathematicians, no surprise there, they claim it's the language of science. Okay? Is math the language of science? Why would it be? Or of physics, they even say mathematics is the language of physics. Why would it be? Math can only describe, and we're looking for explanations. We're looking for causes. So in what way would math be, a language that represents physics? And a lot of people say, they say, all these mathematicians out there, these so-called mathematical physicists, they know all that math, they're geniuses. And people say, oh, I don't understand all that, so they must be right, because they all agree, all these people, all these mathematicians agree among themselves, or a lot of them do, and they have this club, this elite out there that knows all these equations. And the rest of the world, they don't understand any of that, so they say, well, we'll leave it up to them. They'll tell us. Kind of like the people in the Middle Ages, they left it up to the only person who could read in the village, which was the priest or a monk who would read the Bible and tell them what it says, because people had no way of knowing any of that. Well, today we have the same thing. We have these priests of the modern world, as I call them, who interpret the world. After they do their equations, people say, well, how can you doubt them? Who knows all those equations? Well, that's if equations have something to do with it. But there's a more fundamental reason, that I have against that, and that's that a mathematician, a person who does all these high-level equations, he's an autistic person. He's not an intelligent person. He's nothing of the kind. Here's a little clip of that. I want to show you this. For those of you who watched The Rain Man, Rain Man, we had this fellow who was autistic, and he did all these mathematical calculations in his head. He was superb. Was he intelligent, or was he autistic? I mean, is there a difference? So here it goes, okay? This is the piece. Listen carefully. He's going to count toothpicks in his head.
Another check. Sorry about the toothpicks.
82, 82, 82.
82 what, right? How much is this?
Toothpicks.
It's a lot more than 82 toothpicks, right?
But 246 total.
The change. Ray, how many toothpicks are you?
250.
Pretty close. Come on, let's go, Ray.
246.
There's 4 left in the box.
That's a mathematician for you. He's not an intelligent person, he's an autistic person. Okay? And here, let me provide proof and evidence to convince you. Okay? We always like to provide proof and evidence, okay, to get to the truth. Here it is. Okay, we have this Juanito Baez, okay, he's claims to be a mathematician, okay, and these are some of the papers he wrote. And this is just a small list. He's got over 100 papers, but look at the titles. Just look at the titles. You can look them up and find out what kind of language he uses in them, in these papers. And just look at some of these titles. You know, like the fourth one here, on the Hopf term in a two-dimensional sigma model for antiferromagnetics. I mean, what the hell does this have to do with science, with physics? What are these people investigating? I like that other one down there. It says the octonions, and it was put in a magazine called Bull. I think it is a lot of bull, you know, if you ask me. I mean, what is all this nonsense? Just look at the titles. They invented words that have, they can't tell you how a pencil falls to earth, but they have all this fancy language there that they've invented. And they say, oh, we have all these concepts that we understand, and etc. You know, this has nothing to do with science or with physics. What are these people doing? What are we paying them big salaries for if all they're doing is inventing concepts that have nothing at all to do with reality or with science, with physics or science? What is all this nonsense? I mean, you can look at some of these papers that these people have, and it just shocks you all the concepts and notions that they've invented. Here's one that Juanito writes down. You can look at the language. This is just the abstract, okay? Here's the language that he uses. Okay, he says, enriched Love-Veer theories are a generalization of these theories that allow us to describe the operational semantics of formal systems. For example, a graph enriched in Love-Veer theory describes structures that have a graph of operations of each arity, whoa, where the vertices are operations and the edges are rewrites between operations. Great. Enriched theories can be used to equip systems with operational semantics, and map between enriching categories can serve to translate between different forms of operational and denotational semantics. The Grothendieck construction lets us study all models of all enriched theories in all contexts in a single category. We illustrate these ideas with the ski combinator calculus, a variable-free version of the lambda calculus. Is this guy, what language is this guy talking? I mean, you know, what is this nonsense? What is this poppycock? What does it have to do with physics? I mean, this guy's got 127 papers published right now, and they're all like this. It's all garbage. And what is all this abstraction? What is it for? What does it produce? I mean, you might say it might help with technology. Well, we don't care. We're saying, what does it have to do with science, with physics? Can Mr. Baez tell me how a magnet attracts another? Can he tell me how what causes a pencil to fall to the floor? I mean, they have all these equations, all this string theory equations, which are scary out there, you know. And I'll tell you, I've had my share of math out there. Normal math, you know, calculus and so on. But I think this is just ridiculous. They're just inventing concepts for the hell of inventing concepts. And again, I'm saying they're not intelligent. These are not intelligent people. They're not geniuses. They are autistic. They have mental problems. That's the way I look at these guys. So, yeah, I mean, mathematics. So that you keep it in your mind. What is mathematics? Well, it's all this nonsense, that these concepts that they're inventing every day. That's what you're paying for. Okay, before we get to the questions that people made out there, we're going to have a little session here. Let me go over some of the questions that people made throughout the week. Here we go. Okay, a fellow says, No one who's an actual flat earther agrees with the Flat Earth Society or the acceleration theory. It is controlled opposition in Google, etc. He talks about some, conspiracy out there. Anyways, he says gravity is basically a pointless topic to argue about flat Earth because Bill Gates' rope theory can equally be possible on a flat Earth. Absolutely not. And I showed this the other day. I guess this fellow didn't see it, okay? But there's the flat Earth version, the moon and the sun tied by, I guess, ropes, electromagnetic ropes, we're thinking there, to this flat Earth. No, the only way the rope model works, and which explains why everything is spherical in the universe that has a certain size, is because, everything tends towards the center of that sphere. And in this case, you have the Earth, and you wonder why the water and the air curve around the global Earth. Well, it curves around because everything is stuck to the center of the Earth. And there's more matter as you approach the center of the Earth. Everything tends in that direction. In fact, one atom that's on the other side of the Earth is being pulled by the one on the other side of the Earth. So everything tends towards the center. Okay, so only with the rope model can you explain why everything is spherical. You cannot explain why all objects in the universe are spherical with the particle model that quantum and general relativity propose. Certainly not with string theory, which is just a way of representing particles with these strings. So you cannot explain the roundness of the Earth, the sphericity of the Earth with the particle model, or the wave model for that matter. You can only explain it if every atom is physically interconnected. And so for this fellow to say that you can also do the rope model with a flat Earth, absolutely not. Okay, so let's make sure we get rid of all these flat earthers who are distorting the theory. They don't understand the theory. The theory is that all atoms are physically interconnected. If they are, you cannot, we're not saying that the flat Earth is pulling on the moon and twirling them around. That's not exactly what we're saying. They're all bound, yes, but if they're bound, the Earth had better be a sphere, okay, because everything tends towards the center of that sphere. Okay, another fellow, he talks about the definition of an object. He tries to define the word object, and this is what the best he could do. Says obstacle that has been ejected, meaning projected, ejected, etc. In other words, a thing that resists others, that is in motion or projects out, has extension. All the words he's using are verbs. Ejected is a verb, resisting is a verb, extended is a verb, and projected is a verb. All these are verbs. He's talking about motion. Those are known as verbs in physics. And in science, you must define the noun, the thing, before you define the verb, the motion. Okay? Because motion is two or more locations of what? Of an object. And then he uses the word thing, which is a no-no. You can't define the word object using the word thing. Okay? So you can't do that. It's a synonym. So much for his definition. Yeah. Has no place in science. Irrational, totally. Now the fellow tries to define motion. Okay, let's see what he has to say. He says, motion is the phenomenon. Phenomenon is already motion. So you can't say motion is motion. Doesn't make any sense. In which an object, a collection of matter, many objects, also a synonym. You can't say object is a bunch of objects. Okay, so no. And so a collection of matter changes its position. Well, changes is already a synonym of motion, so you can't use the word change. And its position is considered to be motion in the religion of mathematics, so you can't use the word position either. It's an ordered pair. Okay, how to get there? Over time, the interval change occurs. You can't use the word time because you have to define motion before you define time. Time is two motions, comparison of two motions. You need memory for that. But, you can't use time because time has no place in science, in physics. The word motion does. It's qualitative. You don't need any numbers there, okay? But for time, you need numbers, unless you're talking about before and after, which is trivial. And motion is mathematically described. No, absolutely not. Motion is a qualitative concept. Okay, we do not mathematically do anything with motion. Certainly, we don't define it using any quantitative anything. Okay, so yeah, but they try hard. These poor people. Okay, here's another fellow says, I have a hard time understanding how you can possibly explain a mechanism with suitable precision to make quantitative predictions about reality and develop real-world applications of said mechanism, technology, without mathematics or, at the very least, geometry. Like, how would you make a suspension bridge? You can't just eyeball the thickness of the cables and rebuild the bridge if it collapses. Or an atom bomb. There is literally no way you could make that by trial and error, since even the slightest error would just make a radioactive mess. This poor fellow, he thinks that science is about creating gadgets, technology, trial and error, you know. So yeah, that's why he doesn't understand squat, because he thinks that science is technology. It's not. Science is explaining a mechanism. That's what science is about, as it relates to physics. And what he's talking about is something totally different that's got nothing to do even with his channel. So he's in the wrong channel. He should go to a technology channel of some kind. You know, here we do science, physics, not technology. Okay, here we have another fellow says, I disagree with your definition and classification of the word science. Okay, good. So what do you propose instead? Well, he says, if you remove it and replace it with physics, it's better. And then he says, it is always better to return to the initial and original definitions of the terms rather than continue with dangerous pretenses. Whoa. He's saying that we should rely on tradition. Here it is. I guess this is what he's saying. Here's the rundown. It says tradition over rationality. So we have a wrong definition if the Greeks defined everything wrong, or if the Romans defined everything wrong. We should continue with that definition because it's the one we've had for 2,000 years. Is that the reason we should continue with it? And again, mathematics has no definitions whatsoever. We don't have a single definition from the religion of mathematics. So we have to define these words because they haven't defined the word object. They don't even know their own words. They don't know the word energy. They don't know what a field is, you know, or use it inconsistently. They don't know what a point is. They don't know what a line is. So they use all these words and they have no definitions. And they tell you in your face that they have no definitions. They said that if they happen to define it, it would be circular or iterative. You know, it would go on forever and ever and ever. So what we need to do is erase the board completely, start all over again. We have to get rid of the entire dictionary. We can't use words of the ordinary dictionary because they were not defined by physicists. They were not defined by scientists. They were defined by English majors, librarians, people who have no stake in the subject matter. And then what the mathematicians do, you know, they borrow the word, they look it up and they say, oh, this is what it says in the dictionary. And they put it in the encyclopedia and they say, okay, this is what it is. And then when you put them against the wall, they say, what do you mean? I found it in the dictionary. Like if that's the only reason you need to have a word. You just look it up and that's it. And I'm not talking about everyday words. I'm talking about specifically the words that you need in physics, meaning, you know, what is physics about? To explain a mechanism. You need to explain the mechanism of gravity, of magnetism, of electricity, of quantum jump or whatever. In order to explain all that, you need objects. And the first word you need to define in physics is the word object. And in 2,500 years, no one has defined that word. And it's very simple for you to prove that to yourself. You know, go out there and look up any textbook of physics on planet Earth, alive today or for the last 2,500 years. See if you can find a definition of the word object. And not a single textbook begins by saying this is what an object is. So we don't know what an object is. We don't know what motion is because that word is not defined either. We don't know what the word exist means because that's not defined. And it turns out that, you know, physics is above all a discipline that deals with objects that exist, and objects that move, because motion is part of our universe. If you don't have definitions for that, what the hell are you going to try to explain? What is physics about? Then we have to go one step back and ask that question. Okay, another fellow says, to me, about the existence of God, okay? Instead of, if God is not somewhere, then he does not exist, I go by, if God exists somewhere, then he is no God at all. I love that, you know, the first guy that comes up with this notion. In other words, he's saying this. In other words, he says, if God, the object, has location, then that's not God. That's not what he, if it has location, he's just like us. So that cannot be God. So I'm wondering, is he thinking about a 2D God, perhaps? Or, you know, are we talking about God, the concept that has no location whatsoever? I mean, I don't know what God is to him. So he's got to tell me what he means by the word God, if he doesn't mean that God is a thing and that God has location. So then what is God? You know, I mean, again, it's easy to dismiss all that and say, oh, if God exists, if God has location, if that's what the word exist means, then that's not my God. Okay, what is your God? Please tell me. Don't tell me what he ain't. Tell me what he is. Okay, another fellow says, why are magic ropes a better model of electric circuits than electric fields? Other than the fact that you declared only one of them to be an object. Yes, correct. So let's answer the first part, magic ropes. Here it is. Okay, here's the answer to him. Rope is magic in a sense that it has properties that we don't have in our everyday world. In other words, they're invisible, they're intangible, so we can't detect them through seeing and touching. We can't go to a lab to figure it out. That doesn't mean that they're not there, because we have to explain why the pencil falls to the floor. So there's got to be something there. Otherwise, you're introducing, then you're introducing magic. You're introducing magic if you do not put an object there. Then the other thing is, for this poor fellow, apparently, I guess he lives in the jungles or something, because, you know, you have advanced technology, and that's known as magic. To, you know, like pygmies there. If you bring a magnet there or anything, any device, and show him, the guy will go nuts. He say, oh, what a phone that talks, a little tablet that talks. Yeah, for him it's magic. And this is no different. This fellow is being wowed by the fact that we have science, and we're saying that there are these ropes that you can't see or touch. And for him it's new. He said, what do you mean you can't see or touch? What kind of magic is that? And you see it every day. You see, or not see it every day. You see things fall to the floor. Why do they fall to the floor? You can't see or touch the mediators. Are you going to say that there's nothing there? If there's nothing there, then you're doing magic. That's the way it works. Okay, and then we have, the fact that you can't see or touch these magic ropes, right? And they are, in that sense, magic for us, right? No doubt about it. It has these properties like it's flexible, but it's made out of a single piece. You would think that a thing that's made out of a single piece is rigid. We're making the assumption here, because that's one of the properties of the thread, that the thread is made of a single piece, but it is malleable. And this in many ways explains some of the properties that we see in our everyday world, such as, you see water, which is liquid, you see air, which you can't see at all, and you see things like steel, which is very hard. So the thread has the ability to reproduce all these properties, being invisible, of being liquid, of being solid, and so how does Mother Nature do all these tricks? And so that's when you have to say, well, the thread itself contains all these properties within it. Hopefully, if the thread makes up everything that's in the universe, hopefully it underlies all those properties that everything in the universe has. And it's called a rope. Some people say, why did you call it a rope? Well, because it's got the architecture of a rope, okay? And just let me show you this for a second here. Give me a second here. I mean, what does this look like to you? To me, it looks like a rope, a two-strand rope, okay? And I'm saying it has this architecture. It's not made out of atoms. It doesn't have the same properties as this has. It has other properties, but it looks like this. It's a pair of twined threads, so I call it a rope. You want to call it something different? You want to call it the twine threads? You want to call it, I don't know, a string, wire? I don't care. I call it the rope because it has that architecture. And if it has that architecture, what are you going to call it if not a rope? I mean, I don't know why these people get stuck on a word. It's a rope, but it's not the rope of everyday experience. You go to the hardware store, you can buy a rope. But you go to the hardware store, you say, give me an electromagnetic rope, and they say, well, what the hell are you talking about? Yeah, for that you have to come to this site and listen to the theory and the assumptions, okay? Electromagnetic rope only has the architecture of an ordinary rope of everyday, experience. When the mathematicians, when they talk about particle, what are they talking about? Well, they're talking about a little ball. You say, well, I can see a baseball. I can't see the particle. So you can't use the baseball or any ball for that matter as a substitute for what you're talking about and say, look, the particle I'm talking about looks like this, and you show them a ball. Is that a crime? I mean, they could have called it a ball. In fact, they call it a particle, and everybody thinks of a particle as, I guess, a speck of dust, a grain of sand. Everybody thinks that's a particle. Okay? And that's not what it is. In fact, in quantum mechanics, it's what? A wave function collapse. That's what a particle is? I mean, what the hell? Okay, so here we have it. Electricity is not equal to the rope. Okay, this fellow says, why do I use the rope for electricity? We don't. Okay, so I want to clarify that. He's got it all wrong. Doesn't understand it, obviously. Electricity is a bunch of merged shells. Okay, all the electron shells, they're merged, and they form a long row, and the whole row, which we call serpentine, is spinning. That's what it is. Okay, and then what is a field? Well, I mean, he has a better model than the electric fields. Well, the field is a concept. Field means bunch of numbers. That's what the word field means. That's how it's defined. What is a field? A value at each point in space. So there you have a field, a ball with numbers, made out of numbers. That's what a field is. So from ground zero, they get weaker and weaker as you get out of there, because each one of those numbers is followed by a unit. And there you see the other version, the transverse wave version. You see all these vectors. And they're known as electric fields and magnetic field. What is a field made of? Vectors. What is a vector? It's got magnitude and direction. So you can't use the word field because a rope is a physical object. An electric field is not. Field, the word field means concept. You can't put a concept and start doing things with a concept. A rope, on the other hand, is an object. Okay? It's like I said table. You say, oh, that's a concept. No. Table is a thing. You point to it, say table, and everybody sees something there. It's a physical object. Okay, even the one I'm dreaming of. I can put it out there in a paper and say that's what I was dreaming of. Brown one, made out of wood. So even the one I'm thinking of is a table. The word table represents an object, always. The word chair is always an object. The word tree, always an object. The word dog, street, car, house, all those are objects. Okay, that's how simple it is. But if you say words such as mass, energy, field, time, intelligence, data, then you're talking about concepts. Okay, so if you can't distinguish an object from a concept, well, all I can do is send you to kindergarten physics, and you take what is called as Physics 101, and you're going to learn the difference between an object and a concept. Field is a concept, rope is an object. End of story. That's how simple it is. Okay, here's another fellow talks about the rope. He says, if they, the ropes, right, are truly invisible and intangible, they have no existence. And certainly do not belong in a discussion about physics. So this fellow thinks that which exists is that which you can see or touch, that which is not invisible and not intangible. So I guess the air does not exist because we can't see it. And so that table that the Klingon has on the other side of the universe, that doesn't exist because we can't either see or touch it. So that's not part of physics. And again, it's because these people operate or function with the wrong or irrational definitions. They think that existence has something to do with see and touch, and they think that what is an object has to do with see and touch. They've been using these definitions for at least 2,500 years, since the days of the Greeks, and this is what they use. This is the notion they have of what an object is and what existence means. And no, those two words had to be redefined because you can't use those definitions. An object is that which has shape, and existence is an object that has location. It exists by definition, not because you believe in it or whatever. But then he says, and certainly they do not belong in a discussion about physics. Well, this guy looks like he woke up yesterday. Maybe he's Rip Van Winkle, he'd been sleeping for 100 years or whatever, in his case, right? Because, where's this guy been for the last 100 years? Okay, here it is. These are all things that are invisible and intangible as of today. The black hole. You can't see it, you can't touch it. And people say, well, no, but I saw a picture of a black hole. No, what you saw, what they supposedly took a picture of, is water rushing down a drain. What they're showing is stuff that is falling, according to them, right, into the black hole. You're not seeing the black hole, you're seeing stuff falling into a black hole, which they assume is a black hole. Okay? Dark matter, they can't see or touch it. Dark energy, even less. Big Bang, can you see and touch that? The singularity at the Big Bang. Space-time, four-dimensional space-time, they say it's beyond our experience. You can't see or touch that. You can't see space. You can't see time. Are none of these words part of so-called physics then? I mean, let's remove them all, right? The wave, function collapse. Electron, you can't see that. So, yeah, we have a problem because this fellow operates first with irrational definitions, and then he's got the wrong conclusion. He thinks that which belongs to physics is only that which you can see or touch. And so, yeah, again, it shows that he's just a poor ignoramus. Okay? He doesn't understand that see-touch has nothing at all to do with physics. What has to do with physics is explaining a mechanism, and for that you have to make an assumption about the invisible, intangible objects that mediate all these transactions, these phenomena. Okay, another fellow says, see what he says? He says, we are not held to physical mechanisms in physics. So we don't do physical mechanisms. What do we do? Just describe, I guess. Okay. And he says, the day science begins to study non-physical phenomena, it will make more progress in one decade than in all the previous centuries of its existence. My poor guy. What are these people doing in science? These people should be in church praying for their salvation. Yeah, I have no idea what they're doing in physics, Okay, here's another fellow. He says, time dilation is science fact. Belief? Yeah, fact is belief. Okay. Not science theory. Time is malleable. Yeah, we have good old Einie there bending the, the seconds, the time. Poor souls. And they believe all this stuff. They really take all this stuff literally. They say time is malleable. Time can be bent. I can twist it and turn it around. Gravity affects time. Yeah, sure. Here we have one of those. He says the following. He says, if there is acceleration with gravity, there must be a connection to time. Yeah, there you see it. There's the gravitime. There's the connection, a little line there that connects gravity to time. Yeah, if you're talking about physical connection, then that's physics. But if you're just talking about conceptual connection, saying there's a connection between concept known as gravity and a concept known as time, yeah, you got to specify what you're talking about. That's good poetry. It's got nothing to do with physics. You can't say that gravity is connected to time. That's mathematics. We don't care about that in physics. Another fellow says, evidence plays a role in the law. Correct. Now, is the law just religion? Absolutely. Law is opinion. Opinion is religion. Okay? I mean, what is law? Prosecutor tries to convince the jury, trying to persuade them to change their mind to vote for his side of the case. That's not as religion. Law is religion. Politics is religion. All that is religion. Physics, mechanisms. That's it. Okay? And last question before we get to the people here that are online. So an object is that which has shape? Yeah. Is that shape decided by arbitrary stipulation in relation to human psychology, visual perception? No. Hopefully not. We kill all observers in the universe when we do physics. No observer is allowed in physics, okay? And therefore, again, he just makes these assumptions about what an object is, okay? Therefore, dependent on the psychological faculties of a human being, on the visual capabilities of a human being, what happens with objects that human beings disagree on where it ends? Poor fellow. Again, these people have no clue whatsoever of something simpler. First thing we do, we remove the observer. And so I ask him, did the moon have shape before any human or any living entity arose on Earth? Did the moon have shape? Did the Earth have shape? Did the asteroids have shape? Did the stars have shape? So no, the fact that they have shape has nothing to do with observers. Shape is an intrinsic, it's the only, in fact, intrinsic property or attribute of all objects. It's the universal property. All objects have shape. If you can imagine one that doesn't have shape, well, that's, then you can shut my mouth with that, okay? So please point to an object or mention an object that doesn't have shape, okay? And that's one issue. The other one is that he's talking about, the fact that two observers cannot agree on the shape of something. Or we can look at it in a different light and say that gas, usually moves, right? Every second, you throw a little bit of gas out there and it changes its shape. Or you can throw a little bit of liquid, any liquid. Just pour it out there in the middle of space. An astronaut just pours liquid out there and you see this blob just expanding. Okay, and so the question is, you say, well, what's the shape of that? I mean, it looks like it's changing every 2 seconds. I don't know what the shape of that is. I mean, is it round? Is it squarish? Triangular? What shape is that? And so again, these people miss the point, and they miss the point 100 times. The question is not, what is the shape of? The question is, does it have shape? If I put water in a bottle, does water have shape? The answer is yes, it does have shape, okay? And we can probably freeze some water out there and say, see, that water had shape because there I froze it for you so that you could see it. And the people have this notion that because it's malleable, unlike steel, they say, well, steel has shape, yeah. A bar of steel, that has shape. That they have no problem with, even though it's changing its shape. They don't even realize that. But in the case of water or some gas or something, they say, well, that changes its shape every moment. What's the shape? And again, the issue is not what is the shape of it. Does that thing have shape? Hopefully, anything made out of atoms has shape. The shape is where the last atom ends. And you say, well, he's got a different opinion than me on what the shape of that is. We don't care. Does it have shape? And the shape is, again, the last atom on the outside. That's the shape of that thing. You can point to it. When you point to a table, you look at shape, not at what it's made out of. You don't say, well, how many atoms does it have? Where's the last atom? Where does it end? We don't care. It's not a question of knowledge of where does the object end. Does that object have shape, yes or no? That's the issue. Okay, and people have lots of problems understanding that. Okay, let's find out. Let's see what kind of arguments, what questions people ask. Hopefully some of them are intelligent. Well, it says, are electric fields entities? Okay, I kind of answered a little bit of that, I think. Electric field, what is an electric field? Well, electric field is any field for that matter, like not any field, but any field from mathematics, okay? Electric field, magnetic field, gravitational field, all those so-called fields, they're concepts. So they're not entities because the word entity is a synonym of the word object, and an object is that which has shape. Field is a bunch of numbers. A bunch of numbers does not have shape. A bunch of atoms can have shape maybe, but not a bunch of numbers. Okay, so yeah, no, it's not an entity. An entity is is a synonym of the word thing, of the word object, or the word substance. In physics, there's no difference between any of those words, just a synonym. Okay, another fellow says, let's see. He's talking about... He's talking about me. He's talking about observing experiments, the two major steps of scientific method, not that irrational pseudoscience method. No, what you got to determine what is science first step, because if we don't agree on the scientific method, we got to go one step back. What is science? What is physics? What are we trying to achieve? Are we trying to figure out what causes this pencil to fall down? Are we trying to figure out the cause of gravity? I mean, I thought all these hundreds of years, at least since the days of the Greeks, I thought we were trying to figure out how the universe works, meaning what is the mechanism that moves things around in the universe? Why is the Andromeda galaxy attracted to the Milky Way galaxy? Why is it coming towards us? Why doesn't the Earth fly out of the solar system? What's keeping it there running around the sun constantly? Why doesn't the moon fly away? Why does it roll around the Earth? Why does this pencil fall down? Why does this magnet, okay, two magnets there, the round ones, why does that one attract that one? We want to understand what the cause is. Is there something in between there? And there had better be, because I can already feel the tug. You say, but I can't see or touch anything. Yes, hopefully you can't, because Mother Nature does all these magic tricks with invisible, intangible entities. So you will never figure it out by going to the lab. The only way to do it is visualizing how she could be doing it, what mechanism she could be using to do that. And if you're going to talk about mechanism, you're talking about objects. So you have to tell me what invisible object is in that region between two magnets, between the pencil and the floor. You got to identify those objects. And so, first we need to figure out what physics and science are about, and then, we have no use for experiments. What experiment do you propose to detect the invisible, intangible entities? I don't care if you're talking about push or pull. If you have a different mechanism, fine. But what are you gonna touch and see? What experiment do you want me to do? I'll go to the lab. I'll go with you to the lab, okay? You say experiment is part of the scientific method, part of physics? Great. Let's go to the lab. What experiment do you want to run to detect the invisible, intangible entities that are pulling or pushing this pencil down to Earth? Why doesn't this pencil fall to the moon or out of the solar system? That's what you got to explain, okay? If you cannot explain it, I'm not sure what you think physics is. What is physics? What do you pretend from physics? Okay, that's the question. We have to answer that question. Cavendish experiment, mass attracts mass. No, mass is not a concept. It's not a physical object. You can't say mass attracts mass. That's an equation. That's a value. That's how to calculate something. That's got nothing to do with object attracts object. You can say that a pen, right? Here's a pen. Pen attracts a pencil, assuming they were very, very big and they were separated by a certain distance. We apply Newton's equation and say this is attracted to that. Fine, we've got that, okay? But then the question is, you can say pencil attracts pen. You can't say mass attracts mass, okay? Because that's calculation. We're looking for the mechanism. How one object is attracted to another. How is it the moon is attracted to the Earth? Why doesn't it fly away? The moon obviously is being rolled around, swung around the Earth somehow. The Earth is being swung around the sun. Jupiter is swung around the sun. So when you have all these swinging things, all the moons of Jupiter, they swing around Jupiter and so on. Everything is swinging around. Now that sounds like the mechanism seems like something like this. Here we have a string, okay? We have a ball, and this is what it seems like it's doing, okay? Doesn't that seem like what's happening to all this? Earth around the sun, moon around the Earth, the Galilean moons around Jupiter. Isn't this what the mechanism? Is that why they don't fly out of the solar system? In this case, we have a little string that we can see. We say, well, I can see that string. Yeah, you can see this string. But maybe you can't see the strings or whatever that's connecting, you know, the moon to the earth to the sun, Jupiter to the sun, etc. That's what you can't see. And so, yeah, you have to identify the invisible, intangible objects, things, entities, right, that connect all these objects together. That's what no one ever figured out, because everybody says, well, an object is that what you can see and touch. Wrong. No. An object is that which has shape. Not all objects can be seen or touched. Okay, another fellow says, let's see if we can find some more. One fellow says, how does it feel for rational science being included with flat earth and moon hoax pseudoscience? Well, I've been at it for this for over 20 years, so I'm really used to this. I've been treated like a flat earther by so many people out there that, you know, my skin now is made of leather. So for me, it doesn't matter. People have their opinions. That's fine. Everybody's got their own opinions. All I can do here is show you another world for you to consider, to ponder, think about, you know, and try to visualize. And maybe, like me, it explains how this universe works. Maybe it explains it for you. That's all I can hope for. Other than that, everybody reaches his own conclusion. So it doesn't matter to me what people believe or think. Everybody's got their own conclusions, and that's okay. What makes science and physics vibrate is when you exchange differences of opinion. Hopefully not with guns and knives. Hopefully, you know, you sit down, you have a beer, and you say, well, I believe in God. I think God moves everything around with angels. Okay, that's what he believes. You gonna kill him? That's what he believes. That's his experience. That's how he was raised. That's how his folks raised him, or that's how he grew up in going to church or whatever. And so this guy believes in that. And what are you going to kill him now because of that? He's got a different God than you. I mean, I always say I'd rather have God than space-time. I can imagine God. You know, a fellow with a beard and a magic wand doing abracadabra. I can at least imagine that. Okay? I don't know if I'm going to accept that that's how the universe got created, but I can imagine what's going in the mind of this guy, that there's this God that moves a magic wand. That I can visualize. I cannot visualize, I can even start to visualize four-dimensional space-time, which is a concept. And to say that I live within a concept. Now that's a little difficult to absorb, okay? So yeah, I'll take God over space-time any day of the week, or over dark matter or any of those concepts. Okay, let's see. We have, same thing. Well, here we have, a fellow says, hydrogen, most abundant element in the universe. One object. Why are physics... I lost myself. Most abundant element in the universe. One proton, one electron. What would be the structure of the fundamental element thread? Well, it's got nothing to do with the thread, really, in that sense. I mean, you're talking about the atom. We're saying that the atom is again, a picture would be worth 1,000 words, but I've illustrated it many times. You have to imagine a bunch of threads, single threads, straight threads, converging upon the center of a ball. Think of a porcupine that's rolled on itself, and all the quills are pointing outwards radially. That's more or less the proton. And encapsulating that is the electron shell. Both of these are built by the threads that make up the rope. So the rope converges on us. One thread goes around and builds the electron shell. The other one goes straight and builds the proton, what we call the dandelion or the proton star. Okay, that's it. It's very simple. That's the structure that we're proposing. Okay, and that shows that under that model shows that two atoms are physically interconnected. Okay, and you have the rope in between. Okay, so my fists are the atoms. You have this rope that's in between them, and the rope is made out of the same thing, same threads as the atoms which are bound by it. Okay, so I think it's a very simple system. That's the basic system. Two atoms bound by the electromagnetic rope. And then what happens is the atom expands and contracts. By doing so, it torques the rope, and the signal goes to the other end. And then, yes, all atoms in the universe are physically interconnected, which means that you can explain now gravity, because gravity is not really an action at a distance phenomenon. What it is actually we can't see what's in between two atoms, and that's why we think it's action at a distance. There is no action at a distance. That's known as magic, black magic, when you do action at a distance. No, hopefully Mother Nature does her universe a little more rationally, and that is, you know, you have connection between all atoms. Okay, see what else we have here. Okay. Okay, a lot of fighting there, okay? Throwing mud at each other. See if we have any... One fellow says, my only skepticism with the moon landing is how did they leave? How did they leave? Well, I mean, forget about the, you mean from the moon, I guess. Which, I had that question too, by the way. You know, I was not very familiar with the liftoff over there, but I want you to understand that before we sent humans out there, there were a couple experiments by the Russians and by the Americans. In fact, there were 8 experiments. What was it? I think it was in 1966. Don't quote me on that one, but I think it was 1966. They had at least 8 experiments. They did 67, 68, and finally they sent humans in 69. And you can see how they produced that. They have this explosion under this capsule or thing, you know, that goes up in the air, and it locks in with the orbiter, and then it comes back to your Earth. So you have one orbiter going around, okay, that's what it is. And this thing descends on the moon, then they have this explosion that sends it up in the air. Again, in the moon it's a lot easier to send something into what is called escape velocity from the moon. And you know, they just have the orbiter match up with it when this guy comes up. So it's all timed, and, you know, they've done it several times. So if they can do that, you know, what's the difference if they can do that out there without humans and doing it with humans? What's the difference? I think they had that capability, no doubt in my mind. Yeah. Okay, see if we have some more. Anyone with... The physics definition of object gives contrast to the physics definition of space. Absolutely. Space is that which doesn't have shape. Object is that which has shape. You have an antonym. Thing and nothing. Perfect. We got it. Okay. And... frames of movies are location, exactly. What you see in the, remember, we're talking about the universal movie, the one that runs the universe, Father Universe here, right? And from every frame of that movie, if you can conceptualize it, right? What we're looking at, in every frame of the movie, you have every atom in the universe. Every single atom. That's in one frame of the universal movie. Every atom, I don't care what it belongs to, is at a given separation from all others in that frame of the movie. In the next frame of that movie, right, everything has now changed to a new location. Okay, so we have different locations from frame to frame. But what you have inside a frame is a separation between objects. All the objects that are in that cross-section of time, cross-section of motion, which we call location. Very simple. Okay, that's the conceptual notion. That's what we're trying to get there. having an accurate estimate of how many atoms in the known universe, how many ropes would that be physically connecting atom to all other atoms? Well, you're saying it yourself. I mean, there's a bunch of atoms, right? Well, that's unbelievable. Well, I'm not going to believe that there's so many atoms in the universe. Right? Is that what we should say? There's too many atoms. I mean, they're talking about gazillions of atoms in, a few, like 1 meter of, 1 cubic meter of whatever, of space. Like 1 cubic meter of air. You're talking about gazillions of atoms there. And I think that's a small part of the Earth, which is a small part of the solar system, which is a small part of the Milky Way galaxy, which is a small part of all the galaxies in the universe, which is, you could say, is a small part of the universe. So yeah, hopefully there are gazillions of atoms. Do you believe that there are gazillions of atoms? How can that possibly be? And so the fact that you say ropes, yes, the same thing. There's lots of ropes, and the word is lots. There's lots of ropes, lots of atoms, period. We're done. Who cares about how many? If they're going to go through each other, they're going to converge upon atoms, okay? And if they can superimpose, then what's the problem, okay? And if you believe that I invented superposition, no, already quantum had that, okay? And so you got to explain a lot of phenomena if you don't believe in some kind of superposition. What's very difficult to believe in is, or accept as an explanation, is a particle at two places at once. Now that's irrational. But to say that two atoms can somehow converge under certain circumstances, and again, it's not a complete convergence like you have neutron bombardment, where you have two neutrons apparently occupying the same space. Well, maybe they don't, okay? But the point is that I didn't invent, superposition. That's already been around. And so first you got to go criticize the establishment and say, what do you mean superposition? Two angels at the same space? Go talk to the mechanics about that first, not here. Okay? So superposition, I didn't invent that. Okay. If time is two motions, what would be the other motion involved in Planck time besides a proton to travel a Planck length? Yeah, time is two motions, and so I'm not sure what the issue is. You have to define the word time. That way we understand. That way we can compare notes. So you got to tell me what time is, okay, so that we can show which one is more rational. Is your definition, which again, you won't find in any dictionary on planet Earth. They'll say stuff like time is what a clock measures. Like, what does that mean? And we're saying we're giving a definition of what, we don't use time in science. We don't use that word in physics. But we're trying to define what the mathematicians are talking about. And what we're saying is it's a comparison of two motions. You need an observer for that. You need memory. And you're comparing two motions. If that's not the definition, you have to first tell us the definition that you are proposing, that you're supporting, and be able to defend it. Okay? And defending it is important. Not say I found it in a dictionary, or that's tradition, or we all voted for it. Nobody cares about that. Okay. Paul says, you got it backwards. We can touch the field, but not the magic matter particle. Now, you can't touch a field. You can't touch a number. I tried to touch the number 5. I can't. When you put it on a paper, you say, now I can touch it, but you're touching the paper. You're not touching the concept 5, because 5 is a number, and number means counting. That's what it means. The word number is a verb. It's not a noun, not in physics. Okay? For the purposes of physics, counting means that you're going to move your hand 5 times. That's what the word 5 means. And if it means something, it's a concept. And what does it mean? It means 5 movements of the hand. That's what it means. That's how you're counting. You're counting apples, or you're counting whatever. So, you can't say that field, which is a bunch of numbers, is a thing. Yeah, you can't touch a bunch of numbers floating there in space. A bunch of units, a bunch of numbers followed by units. What does that mean? What are you touching? That's a concept. Okay, a lot of infighting there. There's going to be another Ukraine war here. Paul says, dark matter is mathematic unicorn of a dark color. Absolutely. There is no such thing as dark matter. And again, invisible, intangible, but they say, oh, that's part of science. But the electromagnetic ropes, they're invisible, intangible, that's not part of science. That's not part of physics. Yeah, sure. No, there's a whole bunch of invisible, intangible things out there that are part of science. I mean, do you see anything between these two magnets? And you see how they attach. So are you saying that there's something in there, or there's nothing between these two magnets? You might say, well, I can't see anything, so there's nothing. So why does it do that? You know, that's what you got to explain. And if you're not going to put a mechanism, then you are doing black magic. You're the one doing black magic. Okay? You're saying that it's done by what? You know, concept? You better put an object there, a thing, whatever a thing is, to you. Yeah, a lot of infighting there. One fellow says, go find the physics definition of object. Yeah, what is the physics? That which has shape. That is the physics definition of object. And if you got a better definition, hey, bring it on. We'll be glad to consider it. Put in the list in the honor roll, you know, in the idiot honor roll. Fellow says, the nylon rope is an object. The imaginary rope is a concept. No, for that you need to define what an object is and what a concept is. Unless you define those two words first, you can't say this is a concept, that's an object. And yeah, nobody took the trouble of defining object and concept, and that's why people say, oh, that's a concept. Like they look at a triangle, they say that's a concept. No, triangle is not a concept. It's an object. It has shape. Square is a shape. It's an object. It has shape. Circle, all those have shape. Even a sphere, conceptually, you know, it's always drawn in 2 dimensions. But it has this projection, so it gives you an idea that it's got 3 dimensions. So a cube, a sphere, a pyramid, those ideal ones of geometry, those are figures, those are things. Okay, so in fact, Euclid defined them as figures and said that it's that which has a boundary. So he was very close. Nothing has, in that sense, has changed. It's just that they never used that definition. Okay, lots of war there, okay, I guess, fellow says, I can touch the air. Yeah, you can touch the air, but you can't see it. So does that make the air not an object because it's missing one of those properties important for objects, that you can't see it? And again, if the air is on over there in the land of the Klingons, you can't see or touch it. And now what? That air is not an object? Okay, again, does the word air represent an object? That's the question. And hopefully the word air is always an object. Any gas, I don't care what it is, any gas is an object. Plasma is not an object. It's not a thing, because plasma is something that's doing something. That's why plasma is not a thing. Okay, so plasma is a verb. Gas is an object. Okay, so let's clarify those things. Okay, what do we have here? Well, lots of war there. I guess we're going to let all these people fight it out. There's quite a war there. Okay, folks, I'm going to leave you with that. I'm going to see you then next time, okay? And so we'll see you then. Bye-bye.